Welcome back to our discussion on solutions. This lecture we're going to be discussing the molar concentration of a solution, and in your textbook it's pages 190 to 195. By the end of this lecture you will be able to perform calculations involving the molar concentration of a solution. The two formulas we're going to be really working with are concentration is equal to N over V, the number of moles over the volume of our solution, so the number of moles of solute, and we're also going to be using our molar mass formula, where molar mass is equal to mass over moles. And by using those two formulas we can convert any, if we know the amount of solute dissolved in a solution in terms of mass, we can figure out its concentration in terms of moles. So, molar concentration, it's probably one of the most important calculations you're going to learn. Most molecules react based on a mole ratio, not a mass ratio, which means we always need to know how many moles of molecules are involved in a reaction. Our basic formula is still the same. It's still concentration is equal to the amount of solute over the volume of the solution. The difference is, compared to our last lecture, is that we're going to be calculating concentration in terms of moles. Now we'll get right into some examples. Here we have an ammonia solution with a molar concentration of 14.8 moles per liter. We want to know how much ammonia would be present in a 2.5 liter bottle. So, we have ammonia, which is NH3. And in terms of concentration, or in terms of numbers, as soon as we take a look at our units and we see we have a concentration, it's in moles per liter, so the concentration of NH3 is 14.8 moles per liter. We also have a volume in liters, so our volume is 2.5 liters. They're asking us for an amount, so what they're asking us for is N. And so we take a look at our basic formula. Concentration is equal to N over V. We want to solve for N, so I'm going to multiply both sides by V. When I do that, on the right side, the V's cancel, and on the left side I'm left with the formula such that N is equal to CV, or concentration, times volume. Then we simply multiply the two together. 14.8 moles per liter times a volume of 2.5 liters. If we take a look at the math, our liters are going to cancel. We have 1 over liters for our concentration and liters for our volume. And so our answer is going to be 14.8 times 2.5, or 37. So this sample of ammonia contains 37 moles of ammonia, and that's it. So for our next one, we have what volume of, and here we're given 0.25 moles per liter of salt solution contains 1 mole of sodium chloride. And so when we take a look at our units, we see that we have a concentration, again, moles per liter. So concentration is equal to 0.25 moles per liter, and our volume is equal, volume is what we're looking for. I almost wrote down our amount there. And here we're given a number. Our units are moles, so we know that's going to be N. So 0.10 moles. And we're talking about sodium chloride, NaCl. After this example, knowing the molecular formula for our samples is going to be important, because we're going to be stuck with mass, and from the mass we're going to have to come up with the number of moles using our molar mass. So I always start with my default formula. Concentration is N over V, and from there I manipulate the formula to get my unknown where I want it. So I'm looking for V, and now to get it in the right spot, what I'm going to do is I'm going to multiply both sides by V again. On the right side it cancels, and I get VC is equal to N. And since I want to solve for V, I'm now going to divide both sides by concentration. On the left side, my concentrations cancel, and I'm left with the volume of solution is going to be the number of moles divided by the concentration. So N is equal to 0.10 moles. We have to divide that by 0.25 moles. And when we do that, 0.1 divided by 0.25, we get 0.4. And we need two significant digits, so we put down that 0. So 0.40, and if we watch our units, we have moles divided by moles, so they're going to cancel. We have 1 over liters, so our units are going to be liters once we flip that liter over. So 0.4 liters. So the volume of solution is 0.40 liters. So here we go. The mole is important in terms of chemistry, but most of the time we do our measurements in grams. So 99% of the time when we're doing these calculations, we're going to actually have to do 2 steps. One step to get our mass into moles, and then from our moles we can get our concentration. Or vice versa, we might have to work backwards. We might have a concentration and figure out mass. But these are generally the 2 steps. And for this one, we're going to use our molar mass formula. And for this one, we're going to use our concentration formula. So we want a mass of silver nitrate required to prepare a 2-liter solution of 2-liter solution with a concentration of 0.15 moles per liter. So silver nitrate, AgNO3, and I'm going to calculate the molar mass because when I do these calculations, I know I'm going to need it. So the molar mass of silver nitrate is 169.88 grams per mole. And now using that, we want to find mass. We know mass is related to our molar mass formula, but we've been given a volume and a concentration, neither of which are in our molar mass formula. But if we take a look, we have a concentration of 0.150 moles per liter, and a volume of 2.00 liters. So from that we can find N. So we're going to do that. Concentration of AgNO3 is equal to N over V. We want to find N, so I'm going to multiply both sides by our volume. And so the number of moles of AgNO3 is equal to the concentration times the volume. We'll plug those in. 0.150 moles per liter times 2.00 liters, and we get 0.300 moles per liter, or moles, sorry, holy moly, no liters because our liters cancelled from the previous calculation. So 0.3 moles is what we have for AgNO3. Now we want to find mass. So we know molar mass is equal to mass over moles. I'm going to multiply both sides by the number of moles to isolate my mass. And the mass of AgNO3 is equal to the molar mass times the number of moles. The molar mass we've already said was 169.88 grams per mole times the number of moles, 0.300, and we get 50. And we need 3 significant digits, so it's going to round actually up to 51.0 grams. And that's our calculation. So 2 steps, 1 to find the number of moles, 1 to find the mass. Okay, so here we have another one. A student dissolves 5 grams of sodium carbonate into 250 milliliters of water. What is the molarity? Molarity is just another word for concentration. So, molarity is equal to concentration, and it's in moles per liter. So by saying molarity, we're saying we're asking for a concentration, and we want the units to be moles per liter. And so sodium carbonate, Na2CO3, we might as well find the molar mass of that now. So the molar mass is 105.99 grams per mole. We want to find the concentration, so we're looking for a concentration, which means we're going to need an N and a V. Now we have our V. Remember that when we're calculating concentration, we're always going to write our volumes in liters, so it's 0.025 liters. We don't know N, but we do have a mass. So from our mass and molar mass, we can calculate N, and from once we get N, we can find our concentration. So we're going to start with our molar mass formula. The molar mass is equal to mass over moles. We're looking for moles, so we're going to multiply both sides by N, and we get moles times molar mass is equal to mass. We're trying to isolate N, so we're going to divide both sides by molar mass. And so the number of moles of Na2CO3 is equal to mass over molar mass. Plug those numbers in, so we get 5.00 grams divided by 105.99 grams per mole. We do the division, and we get, and so as we're working through these problems, we're only going to write down 3 significant digits because that's what our question asked for, but we're going to save all the digits that we have on our calculator. So on our calculator, we have a 0.0471742617. We're going to keep that number for our calculation, but we're going to write down, this is moles, just the 0.0472. Next we have to find concentration, so we're going to go up here, concentration of Na2CO3 is equal to N over V. And our default formula is the one we want to use, so there's no manipulation. And we get 0.0472 moles divided by our volume of 0.250 liters. Now in our calculator, we're just going to divide that full answer by 0.25. And our concentration is going to be 0.189 moles per liter. We have 3 sig digs. The other way you could write it, if you want to make sure that you have a 1 in the front there, or a number greater than 1, or between 1 and 1,000, would be 1.89 times 10 negative 1 moles per liter. The other way we could write this is 189 millimoles per liter. Any of these would do. Probably on an exam you'd see, or if you were doing a numeric response, the units would either be moles per liter with a times 10 to the negative 1 or in millimoles per liter. So we can also find the concentration of ions. Just to note that sometimes when we're talking about concentrations we use square brackets. So for example, if we have the copper plus ion in square brackets, we're saying the concentration of copper 1 plus is 1.8 moles per liter, and I don't know how that got there, so we'll scribble it out. We're talking about copper 1 ions, not copper 2 ions, so choose one. and we can calculate the concentration of ions by using dissociation equations. And then we use the mole ratio to help us in our calculation. So here's an example. Here, if we have hydrochloric acid and we dissolve it in water, or hydrogen chloride, in a 1 mole per liter solution of hydrogen chloride, so this 1 mole per liter is referring to hydrochloric acid, so it's referring to the concentration of the molecule. It's referring to this whole entity. When it enters water, it dissolves. So when it dissolves, or it dissociates, it forms 1 mole of hydrogen for every 1 mole of hydrochloric acid, and it also forms 1 mole of chloride ions. So in this case, our mole ratio is always 1 to 1, which means the concentration of our compound is going to be equal to the concentration of both of our ions. If we look at compounds that have that don't balance 1 to 1, here we have barium hydroxide, and in this case, if we had a 1 mole per liter solution of barium hydroxide, when it dissociates in water, for every 1 mole of barium hydroxide, we get 1 mole of barium ions, but for every 1 mole of barium hydroxide, we get 2 moles of hydroxide ions. So it's that the concentration of hydroxide, when it's dissolved in water, is actually twice that of our original molecule. Well, here's an example. Here we have a 250 ml solution of iron 3 chloride. We're going to calculate the concentration of the chloride ions. So because we're talking about two separate things, we're going to start with a dissociation reaction. So iron 3 chloride. And the first thing I'm going to do is I'm going to go to my solubility table in my data booklet and just make sure that it dissolves. When we take a look at chloride ions, we see that most things are soluble. The only things that aren't soluble when they're in a compound with chloride are copper 1+, silver, mercury 2, mercury 2+, and lead. So since iron wasn't on that second list, we know that when we take iron 3 chloride, so FeCl3 solid, when we put it in water, it dissociates. So when it dissociates, it forms 1 iron 3 plus ion plus 3 chloride ions. And so when we now that we have an equation, we can start doing some calculations. I'm just going to write these numbers down where they belong. We want to talk about chloride and the chlorides in solution. So I'm going to put the volume under my chloride ions, just to remind me that this is where the calculation is going to be important when we're talking about volume. So 0.250 liters. The mass they gave us is the mass of iron chloride. So mass goes over here, and it's 5.48 grams. And since I have mass, I'm probably going to need the molar mass, so I'm going to calculate that as well. So the molar mass of iron chloride is 162.2 grams per mole. And what I'm looking for is a concentration of chloride ions, so I'm going to write that C underneath my chloride ions. And so now I'm going to use a plan, and in order to find concentration, I need the number of moles of chloride ions, but I don't have that. But what I do have is I can find the number of moles of iron chloride. So what I'm going to do is I'm going to find the number of moles of FeCl3, and once I find the number of moles of iron chloride, iron 3 chloride, I can use my mole ratio of 3 to 1. So for every 1 iron chloride that dissociates in water, I get 3 chloride ions in water. So I have a mole ratio of 3 to 1. And so I'm going to use what's called use the mole ratio. And here's the way it looks. So the first thing we're going to find is the number of moles of iron chloride. And the reason I subscript all my variables is because I have two enzymes I'm going to find. The first one is iron chloride. The next one is just chloride. So I subscript each one just so that I know which calculation I'm doing. So I didn't write it down. We got a mass and a molar mass. So we know that molar mass is equal to mass over moles, and from that we can get that the number of moles is equal to mass over molar mass. So that's what I'm going to use to find out my number of moles, mass over molar mass. So 5.48 grams divided by 162.2 grams per mole. And we get 0.338 moles of FeCl3. And now I'm going to use my molar ratio to find out how many moles of chloride ions I have in the solution. So the next step is the number of moles of chloride ions. And I know this is going to be the number of moles of iron 3 chloride I'm going to multiply that, and to get my molar ratio right here is what I'm going to do. I know I need to get rid of, I'm going to go back to my equation, I know I need to get rid of iron 3 chloride in my units, so I'm going to put the number of moles of iron 3 chloride on the bottom. So that way when I multiply by this ratio, my iron 3 chloride and my iron 3 chloride will cancel. I want the number of moles of chloride ions. So, and now I take a look at my numbers. I go back to my equation, and I see that I have 3 moles of chloride ions for every 1 mole of iron chloride that dissociates. So I'm going to take the number of moles of iron chloride and multiply it by 3 over 1, or just multiply it by 3. Dividing by 1 isn't going to change anything. So the number of moles of chloride is going to be 0.101 moles. And here, since I have a chloride written down as a subscript, I'm not going to write any more. I'll write it down at least this once anyway. So I have 0.101 moles of chloride ions, and now I can find concentration. Concentration of chloride ions is equal to N over V. My N is 0.101 moles. My volume from the question is 0.250 liters. And so I'm going to answer in moles per liter, and the answer is going to be 0.405 moles per liter. And that would be how I would leave my answer. Generally speaking, if I just have one digit behind the decimal, if it's not 0.000 something, I don't worry about whether or not that 4 is moved up so it's higher than a 1. Alright, so here we want the mass of magnesium nitrate needed to make a 1.5 liter solution with nitrate concentration of 0.3 moles. So we want to use magnesium nitrate, but we're only interested in the concentration of nitrate. So we're going to do dissociation equation. Anything with nitrates are soluble, so we have Mg, and nitrate's 1 minus, magnesium's 2 plus, so it's going to be MgNO3 solid. When we put it in water, it dissolves to make 1 magnesium 2 plus ion plus 2 nitrate ions. And so we need a mass of magnesium nitrate. So I'm going to put a mass here because that's what I need to find out. The volume of solution I'm going to put under the ion that I know the most about. So I know the concentration of nitrate is 0.30 moles per liter. And so I'm going to put the volume underneath that because concentrations are related to the volume of solution that they're in. So that's where I'm going to put the volume. In order to find mass, I'm going to need molar mass, so I'm going to find that as well. So the molar mass of magnesium nitrate is 148.33 grams per mole. And now I have to make my plan. What I'm going to do is I'm going to find the N, the number of moles of nitrate ions, first. Once I get that, I'm going to use mole ratio. And mole ratio is always the middle step to find the number of moles of magnesium nitrate. Once I find that, then I can find the mass. And I'm always, before I start a question, I'm making a little plan in my head just so I know how I'm going to approach the question. So it's always good to think about what you want to do before you start doing it. So I'm going to start with concentration is equal to N over V. I want to find the number of moles. So I know that N of NO3 is equal to concentration times volume. Concentration is 0.30 moles per liter times my volume of 1.50 liters. Multiply it through, and we get 0.45 moles. And that's of NO3. Now we want to find the number of moles of Mg NO3, and so we're going to take the number of moles of nitrate. Holy moly. Alright, let's try erasing my mess here. So we'll just clear that up and we'll try it again. Okay, sorry about that. So we got our 0.45 moles. I'm going to multiply that by, and this is moles of nitrate. So, in order to get my mole ratio right, I want to get rid of the moles of nitrate. So I put that on the bottom. I want an answer in moles of Mg NO3 2. Fix this one too here. So my mole ratio is going to be the number of moles of nitrate is 2. It's going to be on the bottom. So and number of moles for a balanced chemical equation, we have 1 mole of magnesium nitrate. So it's going to be 1/2. So we're going to multiply our answer by 1/2, and we get 0.225 moles. Now we can take that and we can find mass. The mass of Mg NO3 is going to be equal to molar mass times moles. The molar mass we said was 148.33 grams per mole. And the mass, the number of moles is 0.225 moles. So we're going to need 33, and we only have 2 significant digits from our concentration, so our answer is going to be 33, and the answer is going to be grams. So make sure you get that balanced association equation, and then from there make a little plan and then just follow your steps. And here's a whole slew of practice problems for you. And once you're done that, I'll see you at the next lecture.